Okay, welcome to lecture 10.6. Okay, here's where we are now. Okay, we've talked about Signorino model. We talked about how to replace the U's. Instead of doing like we did with an experiment where the U's were just some number, they were like the dollar value payoffs. Instead, Signorino says, well, instead we can make them um, something we can estimate, and they're an independent variable times various coefficients, and that's what the U are. The U of status quo, U of W1, U of C2, and so on. Um, okay. Uh, Now, the great thing about that is that Signorino explains how he can use his model on what I'm calling real data, not just experimental data. So, data where we have independent variables on a country's domestic assets, military assets, those are data. And we can use those to estimate things like probability that countries will go to war or not. Okay. Now, to start off with, in fact, my lectures, I'm not going to use real data. What I call real data, what I call real data, non-experimental data. So, what Signorino next does is he says, let's generate some simulated data. Okay, so this is. I was using real as a synonym for non-experimental. Okay, that was probably bad form. So what I'm going to do now, we're going to have non-experimental data. So in that case, you you could call it real, even though, but it's going to be simulated, so it's not really going to be real. So okay, I hope you know what I mean by that. So let's talk about how Signorino simulates this data. Okay, now here's the punchline. Here, or one of the punchlines. What he's going to do is he's going to use his theoretical model, use all the assumptions, all the setup in that theoretical model to generate this theoretical data. And then what he's going to do is excuse me, not that theoretical, the simulated data. Then from that simulated data, he's going to estimate parameters. And the key is, and this is always good anytime you're doing structural model, just to see if you've set up your software right in R, generate some simulated data, estimate parameters with that simulated data, and then check to make sure that your estimated parameters are very close to the parameters you set in the simulated data. Okay, so if that may not be perfectly clear, but if not, I think it will be pretty soon. Okay, so here is first. Okay, so now where in the world Kurt Signorino is going to generate some simulated data. First of all, the assumptions when he generates the simulated data. Okay, first, beta 1a equals beta, I think it was a first and 2 anyway. Beta m1 equals beta m2. So this is like your own domestic assets. That's your own military assets. That's the other country's domestic assets. Remember, all the data are going to be a two-country pair. So you've got to know, designate one of the countries one, the other one two. So you got to know one's assets and two's domestic assets, one's military assets, so on. Okay, all of those under these assumptions, he's going to make it simple. He's going to set all of them equal to 1. He could have done anything. Okay. Now, recall that he also, it's not really an assumption. It was just a way to get around identification problem. He set lambda equal to 1. Oh, and then finally beta sub d. This is the democratic peace coefficient. So if both countries happen to be democracies, he's going to assume that both of them have a greater preference for peace. Little ad hoc, but this is important. It matches the data, and this incredibly well documented empirical regularity in the international relations literature. So beta D is going to set equal to 20. All right, so now those are assumptions. Now in a second, I'm going to talk about how he generates independent variables. Okay, hold that thought for a second, but tell you what I'm going to do. So this is like telling a joke, and you tell the punchline immediately. Let me do that now, and I'll come back to the punchline. By the way, this is another tip on doing research. This comes from my colleague at UCLA, Jeff Lewis. I'm plagiarizing from him. He tells grad students, especially when you're writing the introduction of a paper, he says, we're not writing mystery novels. Okay, a lot of grad students want to do that. They don't tell you what the main point of the paper is until the 8th paragraph. They think, oh, I got to build the suspense. Well, what happens is the typical reader doesn't read after one paragraph. If you've bored him or her after one paragraph, that person has stopped reading. You gotta get to the punchline quick, okay? Usually by first or second or third paragraph. You gotta do that. Here is the main results. Here's why it's a contribution, okay? All right, so let me do that. All right, here is table 1 from Signorino paper. All right. So these results, strategic versus, okay, table 1, this uses the simulated data. So I'm going to talk about how we're going to simulate the data. And you simulate it from a model that incorporates various assumptions. And some of those assumptions were all the betas were 1, except for that beta D, which equals 20. All right. Now, I want you to look in that strategic column. What he does, he generates the data, and then he estimates. He uses what we've talked about. Sets up a likelihood function, maximizes it, and then gets estimates of. So military 1, that's beta M sub 1. Military 2, beta M sub 2. Assets 1, beta A sub 1. Notice that all the values are very close to 1. And he puts the standard error in parentheses. In fact, none of them are significantly different from 1. So, hey, he says, hey, it looks like my R program must be working if I'm recovering my initial assumptions. Okay, notice democracy, 19, that's that democratic peace. That's beta sub D. And it should be about 20. Sure enough, it is. Okay, you cannot reject the null hypothesis that really is 20. All right, so he recovered, the parameters that he assumed. Now let me give another part of what else is going on here. First, a story. When I was a grad student. In fact, this is going to be actually. I think it was like my first year after being a grad student. But I remember talking to one of my old professors who, I won't say his name, but he was a guy, kind of traditional political scientist, and very strong opinions, very colorful guy, funny guy, likable guy. Everyone likes him. But I was talking with him about a paper I was doing with Keith Grable. And I'll talk about it actually at the end of this lecture, and it's going to be the subject of the next lecture. It's a structural model to estimate retirements from Congress. And this other professor, the colorful one, starts, saying, you know, why the hell can't you just do a rat shit regression? Sorry for the PG language. Story's not as good if I don't use that. And what he meant is, why do a structural model? Look, why do you have to do all this complicated stuff? You're just trying to show off and impress people. Well, maybe not. Sometimes, the structural model is what you need if you're going to accurately represent what's going on in the underlying data. Now, Kurt Signorino. Okay. Someone might have asked, why do this structural model? Why not just do a rat shit regression? And so he doesn't do a rat shit regression, but he does a rat shit logit. Okay. That is in this column. Sorry. So it's called the naive model. The naive model. By the way, I'm going to get to this. I told you there's two ways to do that structural model. We could have had an independent variable that takes one of 5 different values: status quo, C1, C2, W1, W2. But Kurt also says, well, what if we don't really know who started the war? We don't really know who capitulated and who was the aggressor. All we know, suppose all you can observe is whether there's a war or not. Okay, there's war or peace. All right. That's going to be the dependent variable that we're going to use. I'll talk more about that in a second in this table 1. So Kurt does his structural model. That's in column 1. And then column 2, he does what he calls the naive model. And all that is a logit model where the dependent variable is war or peace, and then he throws in the data. Military assets country 1, military assets country 2. And can you see this? Notice like all the coefficients, almost all 0. You get like nothing. And that log L, that's kind of that. Well, that's the value of the likelihood function. Notice it's a huge jump with the correct model, the strategic model, the structural model. You get a negative 140. When you just use the rat shit logit, you get negative 505. That is a huge difference in terms of the log likelihood. Okay, so that's where we're going. Okay, let me next give you a little more assumptions or details about what's going on when he simulates the data. Okay, now first of all, here's the assumptions about the parameters. Okay, we're going to use these parameters to generate the data. Second, the independent variables. And then, first of all, Dij equals 1 with probability 0.2, 0, probability 0.8. Okay, so that's just a binomial random variable, Dij, 1 or 0, equal the 20% chance. That, it's kind of unfortunate. He assumes that beta D is 20, and that's at probability 0.2. He didn't. They don't need to be. They're not related. He could have made that anything. In fact, I wish he had done 0.3 or something, just so there wasn't confusion. Beta D next. All right, another independent variable, M1. Okay. All he did, so that's, we designated country 1. He's going to draw a uniform random variable in between 0 and 100. So M1 is something between 0 and 100. Okay. M2, A1, A2 are the same. Okay. He does with every case. So every case, he's going to pick a country 1, country 2, draw a random variable for M1, draw a random variable for M2, for A1, A2. They're all uniform, 0 to 100. All right. So now he's got all the he's got all the independent variables, or for say one observation, he has all the independent variables. We already know all the coefficients, all the parameters. Okay, then from there, what are we gonna do? Where is it? We can just substitute in all those variables and put in the u's. Okay, fill in the u's. So beta d, that's 20. Dij, that was either 1 or 0, depending on the draws. So u1 of status quo is something, u2 of status quo. It's something similar. We know this just from what we've drawn. We can do the same thing. ui c1, ui c2, ui c, and then he does, I guess, something. So instead of using UI W1, UI W2, he assumes that war is the same outcome, no matter who starts it. So UI just war is this term. So remember, the PIs just come from the M's. It's, P1 is M1 divided by M1 plus M2. Okay, so we've got the P's, that's data, the A's, we got everything. So we can say what UI, now, by the way, these are, I didn't put stars on these. These are the scene utilities, okay? The total utility would have an error term on it that comes from a Weibull distribution. But it turns out really all we need is the scene utilities for the moment. Now, from each of the, we've got all the scene utilities, and then the key was we had P4, P1, Q2 and Q3, and those were the probabilities that each actor goes to the right branch or left branch on that game tree. Okay, but so we have those 4 probability terms, P4, Q3, Q2, P1, and they all look like this. Okay, notice they're a function of the scene utility, but we've already calculated the scene utilities. So, and remember, we set lambda equal to 1. So with all of these probabilities, we can fill in their actual value. Okay, so P4, that's going to be value, 0.68, something like that. We can do that with Q3, Q2, P1. All right, then once we do that, we can start simulating the outcomes so that we can get a dependent variable. Okay, the way we do that, sorry, you know what, I realized, I think I had some typos or rightos on my earlier. So I redid this figure. I had P2 there, and it should have been Q3. So I think I may have had a mistake there. I had that should be Q2. I may have had something else. Anyway, so we now have the Q2s, Q2, Q3, P1, P4. Remember, those are just functions of the scene utilities, which are functions of the betas and the independent variables. So we can fill in all of those for a given observation, for a given trial. We can fill in what all these p-values are, okay? Given that, we can now simulate what happens. So suppose we're on trial 1. We've drawn independent variables. We filled in the utilities. We filled in these probabilities for trial 1. Now let's simulate the data. So suppose P1 equals 0.68. All you have to do it on a spreadsheet, draw a uniform random variable. So, and if that uniform random variable, so I said P1 is 0.68, if it's below 0.68, that uniform random variable is below 0.68, you say we go this way. So P1 is the probability we go a big F1, that we go down that branch, okay? On the other hand, if the draw of that random variable is above 0.68, we go down this branch, okay? So that's what we do. We draw that random variable, decide whether we go that branch or that branch. If we go down this branch, we next draw another uniform random variable and compare that to Q3. Then that decides whether we go down this branch or that branch. Okay. On the other hand, if we'd gone down this branch, we do the same thing with Q2 and so on. Okay. So we start drawing random variables, decide which of these endpoints we go to. Okay. Now, Kurt, so he can compare it to the rat shit logit, he collapses these outcomes into just war or peace. So if we get to status quo, C1 or C2, we call that peace. And then if we get to W1 or W2, we call that war. And remember, I think it's from the first or second segment of this session, I talked about how to do the likelihood function when we collapse the dependent variable into one of two outcomes rather than one of five. Okay, so we have that. It's one of two outcomes. We can write that likelihood function. And the key thing is that for this first iteration, this first trial, we can state what the outcome of the dependent variable was. So depending on our draws, we may have gone here. If so, we'd say the outcome is war. Okay, y sub 1, big Y sub 1 equals 1. Okay, if we go to something else that's peace, y sub 1 equals 0. All right, so now we've done all the simulations for trial 1. Do the same thing for trial 2. Okay, generate independent variables again. Keep the same parameter values. All the betas are 1. Beta D is, except for beta D, which is 20. Generate a new dependent variable. Okay, we're going to use those independent variables. And our draws on P1, draws uniform random variables, which we'll compare to P1, Q2, Q3, and so on. That's trial 2. Okay, you do that a whole bunch of different times. Kurt does this 1,000 times. Okay, so he has 1,000 trials of simulated data. Once he has that simulated data, he pretends like he doesn't know the values of the parameters and says, let's try to estimate it from that simulated data. And the great thing, as you see, once again, for the strategic model, his estimates are close to, very, very close to what the assumptions he made when he generated the data. So that means he didn't make mistakes in his R program when he was estimating those parameters. Okay, then finally, let's see. Just in the naive model, okay, that's where you just use those independent variables to estimate the rat shit logit. All right. Now, some of the international relations people say, look, you didn't include everything that's relevant. So maybe what you should have done is also include a variable. I think they call it military concentration. Is that right? No. No, balance of power. I think that's when the military concentration. So you just look at M1 divided by M1 plus M2. And then I think all that was is you look how close that is to 0.5. So you just take that, subtract it from 0.5, take the absolute value of it. And so in the international relations, people, they say when both countries have about the same military power, the relative military assets for both is about 0.5, you get peace. And so Kurt threw that in as another independent variable, and sure enough, I think it does better. Actually, no, not that much better. Tried another one and called it the joint utility. I can't even remember what's going on there. But a lot of these, you would say the rat shit logit, does not match the theory, okay? What often happens, especially in international relations, they'll say, well, we have these ad hoc independent variables that will proxy for the theory. Things like that military concentration, joint utility. And Kurt's saying, okay, yeah, those are best approximations for what's really going on in the theoretical model. And sure enough, he shows this. He says, even when you add on those, those extra created independent variables, they really don't do that much. And so I would argue that this table one, it's very important. This is a justification. This says, here's why, at least at times, you need to do a structural model because one, you're not accurately capturing what's going on in the data. So sometimes students ask, why do structural models? That's the best answer. Sometimes to match what's going on in the data, you got to do a structural model. And just one of these ratchet regression, that might be a good approximation for what's really going on in the data, but sometimes it's not. And Kurt Signorino showed, look, in this case, at least with this one example of simulated data, it was not a good approximation of what was going on. Finally, before I end this segment, let me say one more thing, and I think I forgot to mention this when the session when I was talking about media bias. Another reason to do a structural model. So I did a structural model to estimate media bias. If I hadn't tried a structural model, I would have no idea how to estimate that, how to get a measure of media bias. I had this idea in my head, this has got to be something like nominate scores. Now, nominate scores has a structural model to it, but I don't think if I just said, there's got to be some way to do a logit or probit, I don't think I could have come up with a way to do it. I think the key is I just started writing down, well, let's talk about utility of a member of Congress, utility of a media outlet, and their utility for citing various think tanks. Once I did that, and once I'd read the McFadden paper and read the nominate stuff, it was pretty easy coming up with that structural model. But if I hadn't tried to do a structural model, I don't think I would have come up with any way. I would have thought of any way to try to estimate this. So that's one more reason. It helps give you ideas about the proper way or a way to estimate some things. Okay, so that is table one. Okay, but the finale, I want to get to, I think it was figure, let me see what it was. It was figure 3. Okay, that was the case where I told you at that meeting of the political science methodologists where everyone was really, really impressed. And so that's where we're going to get to next, figure 3. Okay, so that's the end of this segment, and I'll explain that figure 3 in the next segment.